In the previous slide, we saw the steps used for capability analysis of continuous data. In case of discrete data, we do attribute analysis. The difference here is that we do not have to do normality check. Instead, we calculate DPU and check that value in Z-table to find out Z-scores. With the help of Z-score, we calculate capability indices and make inference. As we do for continuous data, capability baseline and sigma level calculation is done for attribute data also. The Z-score effectively transforms the actual data into standard normal units. By referring to a standard Z-table, we can estimate the area under the normal curve. Attribute data is always long-term in the shifted condition, as it requires many more samples to get a good estimate with reasonable confidence. Short-term capability is typically reported, so a shifting method will be employed to estimate short-term capability. Here in this table, in case we have long-term data, we can add 1.5 to convert it into short-term capability, and if we have short-term data, we can subtract 1.5 to convert it into long-term capability. Why the figure 1.5? That is because a stable process can shift and drift by as much as 1.5 standard deviations. Now to get CPARC and PPK, the capability indices corresponding to short-term and long-term data, respectively, we can divide the Z-score by 3. So the equation for Z-score looks like this, and for CPK and PPK, it looks like this. Let us understand what we have read so far, with the help of this example. Quick Info Call Center is interested in estimating the capability of their team. A total of 10,000 calls came in during the month, but 1,000 of them dropped before they were answered. Here is the results of the call center dataset. 1,000 defects or call drops in 10,000 calls. To calculate the sigma level, we first calculate defects per unit, which comes out to be 0.1. Then we look for this value in the Z-table. Z-score is 1.28. Now, we convert the Z-score to CPK and PPK. Z long-term is 1.28, thus Z short-term can be calculated by adding 1.5, and we get 1.78. To calculate CPK and PPK, we'll divide these values by 3 each. We can see that the process doesn't look capable. Do you remember the ideal value of CPK? But we don't have to panic at this moment. Right now this value is used as a benchmark, since we will have to show the improved capability when we get to the control phase. The sigma level for discrete data can be calculated in similar way using the template in Sigma Excel, as we did for continuous data. For the example that we just discussed, the process sigma level is 2.782. In the measure phase, we learned about the various tools and techniques used for process definition. We covered descriptive statistics, normal distribution and normality analysis. We also learned the characteristics of measurement system in terms of accuracy and precision. We saw the basics of process capability. We learned the difference between control limits and specification limits. And in last few minutes we learned about the capability indices, capability analysis for continuous and discrete data. Here we come to an end to this lesson. Should you need any support, feel free to contact us. Thanks for watching this video, and see you in the next lesson.